So this is one of the more challenging questions in the homework about the formal definition of a limit. As we have a complicated function with this quadratic here, and then we have this interesting information about delta to deal with. So let's give it a try together. So I want to justify the limit, and then we have to figure out what this information about delta means. So we have the limit as x approaches 3 of the function x squared plus x, and the limit is 12. Epsilon here is some arbitrary number greater than 0. So remember, epsilon is just some small change in y. We want to figure out what the corresponding change in x should be. So that's what the delta is. And here it says, okay, you're going to choose a delta that's the minimum of either epsilon over m or 1. And we got to figure out what m is in this situation. So let's just start off with the idea of the formal definition. So the formal definition basically tells us to start with f of x minus L, right? The difference between some y value and the limit. And that has to be less than that small change in y. So we want the distance between any y value and the limit to be small. So we're looking at y values very close to the limit. And we want to figure out what x values we can choose and how close they need to be. So this delta is how close any x value needs to be to a here. And so plugging in the information for this one, our function is x squared plus x. Our limit is 12. And epsilon is just some small number. And we need to get that to look like x minus 3 is less than delta, so we can figure out how to get delta. And the claim here is that delta should look like epsilon over some number m. We just got to figure out what m is. Or delta could just be 1, which is kind of interesting. What happens if we just let delta be 1? So I'm just going to maybe do that part first. So if I take this and put them together, focusing on the 1, because that's a lot easier, I would get x minus 3. The distance between x and 3 has to be less than 1. So if we look at that on a number line, here's 3 in the middle. And this says you could go 1 to the right, right? So the distance between any x value and 3 is at most 1. So 1 to the right, let's say that's over here at 4, and 1 to the left would be over here at 2. So this interval notation right here with the absolute value says x has to be some number between 2 and 4. All right, so let's see, I don't know how to use that yet. Let's just go over here and play around. What can we do with this? Well, this factors, right? This factors as x minus 3 times x plus 4. So now I have this absolute value here. All right, let's see. Well, I'm getting close because I see an x minus 3 here, and my goal is to get the absolute value of x minus 3. Now, this x plus 4 is kind of in the way. I'd like to get rid of that. Well, in the limit here, x is approaching 3. So that means the only x values I care about are x values close to 3. If x is close to 3, 3 plus 4 is 7. This is close to 7, right? So x plus 4 is around 7. Well, I can pull that out. So my claim here is that since x is close to 3, this is positive, and so I can factor it out. So I can say this is the absolute value of x minus 3 times x plus 4 is less than epsilon, and then I can divide that to the other side. So now I have x minus 3 is less than epsilon over x plus 4. And now this is starting to look like that up here. I have epsilon over something, but that x is in the way because I'm assuming m here is supposed to be some number. If I go back to the problem and click on that box, it says enter a number. Okay, so I can't plug in an x there. Okay, well, if I look up here, according to this, I can choose delta to be the minimum of epsilon over m, or 1, and that 1 forces x to be between 2 and 4. The bigger the denominator is, the smaller the fraction is, so I would think I should pick the biggest number I can for x. So based on this, I'm going to let x equal 4 down here. So I'm going to say that's epsilon over 4 plus 4, which is epsilon over 8. And remember, we want epsilon and delta to be small numbers. And based on this information, that's like the smallest I can get. If I picked epsilon, x to be 3 or 2, right, I would get a smaller denominator, which makes the fraction bigger. Yeah, that seems reasonable. All right, so I think that m should be 8, according to that. Cool. Boom, done. Have a good day. Do good math.